Thank you very much for the opportunity to present to you about a new locality for phosphate nodules in the Canadian North, notably in the Northwest Territories rather than the Yukon, specifically at the Little Fish River. The locality is shown roughly here in Little Fish River or Little Fish Creek. It has been called both. The locality more specifically is a small tributary of the Little Fish River and is in the Northwest Territories. Here on the map on the right, it is shown in relation to previous known phosphate deposits in the Yukon at Rapid Creek, Crosscut Creek, Big Fish River, and Boundary Creek. The geology of the deposit was not within the scope of this project, but the geology described from the assumed to be similar deposits in the Yukon shows that they are of lowermost Albian age. The deposits occur in shale, mudstone, and ironstones, and occurred due to deposition in a shallow marine environment. Here are some photos of the locality demonstrating the appearance of the local geography and geology. The nodules can be found very much similarly to Big Fish River as nodules in talus, but also can be found in situ. At Big Fish River, they have been described to resemble ammonites and pelecypods with distinctive features highly suggestive that these formed after fossils. Here's an example of phosphate nodule from Little Fish River. You can see that once they are broken up, the minerals inside can be seen more clearly. Dimensions given in this talk are for the largest of any sample in a series. So the aim of this study was to use analytical techniques to determine the minerals inside, see if they were similar to those already described at Big Fish River. The analytical technique selected due to convenience as well as it being non-destructive and relatively easy to perform was Raman spectroscopy. This was done both at the University of Arizona as well as subsequently at McGill University. And the important thing was having a good reference database by which we could compare our spectra and data. Fortunately, the database at the Rough project is quite robust when it comes to phosphate minerals from the Yukon. For most of the species implicated, there was reference Raman spectra, including microprobe and single crystal XRD data confirming the reference minerals. So the first mineral we will talk about found at Little Fish River is maritite, probably one of the most prolific of the species of phosphates. The most common mode of occurrence was in nodules where maritite makes up most of the nodule as seen here as sprays of maritite crystals. These sprays tend to have a duller luster. They tend to be broad. In this particular sample, in the lower portion of it, there's also some ludlamite as well as a spot of pyrite seen in the middle portion. Here is the Raman spectra for that particular sample, showing a strong correlation with the rough reference sample of marachite from Big Fish River. Here's another example of marachite, in this case more of a brownish color and curved blades. And another sample, this one more of a olive color, although the greenish coloration is due to two other as of yet unidentified minerals occurring as a surface alteration. Another occurrence of marachite is in nodules consisting of several phosphate minerals. In this case, the marachite forms more towards the periphery of the nodule and tends to be colorless or gray in color, light gray in color, and essentially anhedral. Similar in appearance to quartz, but without evidence of conchoidal fracture. These nodules, you can see the marachite in the periphery, reddish patches of wolfeite, pyrite, and more caramel brown sprays of saturlite towards the middle of the nodule. Wolfeite has been found in occurrence as sprays. These sprays of crystals tend to be more narrow and have a more reddish color and slightly greater luster than the marachite. Here we can actually see both marachite and wolfeite are present in this nodule. The wolfeite indicated with the arrow, whereas the marachite is more gray or colorless and comprises most of this nodule. Here is the Raman spectra for that sample of wolfeite, showing good correlation with again, a reference sample from Big Fish River. Another occurrence of wolfeite, as mentioned previously, these reddish anhedral patches in, again, nodules composed of several phosphate species. Saturlite occurs commonly as well, tends to be more in the central portion of the nodules, has a higher luster, more of a caramel brown color, indicated by the arrow here. The Raman spectra for that sample again shows strong correlation with saturlite from Big Fish River. Another example of saturlite clearly seen towards the center portion of a nodule, again surrounded by grayish to colorless marachite. Ludlamite is found and best identified by a platy appearance, almost cleavages, entirely anhedral, and usually occurring together with other phosphate species, especially marachite. Here is an example of two nodules showing ludlamite. It is usually a gray to grayish brownish color and not the characteristic green that ludlamite is usually known for. Strong correlation with ludlamite from other localities. Again, this ludlamite is not characteristic of the usually more popular greenish crystals for collectors, such as this one from Big Fish River on the right, but is known to occur in this habit at Rapid Creek, as can be seen in this example on the left, whereby this sample was actually analyzed by the University of Saskatchewan. Vivianite occurs as a bluish colored mineral generally in the periphery of some nodules, I cannot be certain it is vivianite versus barachite or metavivianite, since I'm not convinced Raman can distinguish between these three minerals, and all three have been reported at Big Fish River. Finally, pyrite was also identified by Raman, common in nodules, as can be seen here. So in summary, nothing very surprising, because all of these minerals have been found at Big Fish River, but also confirmed here from Little Fish River. The main phosphates are marachite, wolfeite, satyrdite, ludlamite, and vivianite, with accessory pyrite and quartz. Thank you to McGill University and University of Arizona for allowing me to use the Raman for this study. The usefulness of these nodules appears to be for lapidary purposes. Apparently they cut nice and take a very nice polish, so we may be seeing them in the market in the future for this reason.